Okay, good morning students. So now we are with the last question number 3, Roman number 7. This is the last question under question number 3. Then from next video then we will go with the different types of parabola, different concept. Okay, so under this, now this question, many students faces problem with this question. So actually it's not that difficult. It's very simple. So listen carefully here. See, in this question you need to find the equation of the parabola where the focus is given at -2, -1 and the lattice rectum joins the point these two. Okay, anyhow focus is given -2, -1, so -2, -1, so this becomes the focus. And then there is one lattice rectum who is joining these 2 points. One point is -2, -2, -2, -2. Somewhere here, okay, let me write, okay, -2, -2. And another one is -2, -4. It is somewhere here, -2, -4. Okay, let me draw the lattice rectum because this is the lattice rectum which is joining the 2 points. One is -2, -2, that is -2, -2. Another one it is -2, -4. And we have this focus which is -2, -1. Let me draw one lattice rectum. This is a lattice rectum. We have focus. This lattice rectum is joining these 2 points, -2, -2 and -2, -4. So now, this is the lattice rectum. Now tell me, what will be the parabola here? Concave, right, left, up or down here? Up and down, no chance, because here up and down means lattice rectum should intersect y-axis. If it is concave up or concave down, it should intersect y-axis. But here lattice rectum is intersecting x-axis. So we have 2 possibilities. It can be concave right or it can be concave left. So in this case, you are going to get the 2 equations of parabola. Here see, so it can be concave right. I don't know, let me draw a concave right. Another one can be a concave left. Okay, let me draw here. Okay, concave left. I know it's just a rough drawing. This is just a rough drawing. So that means we have 2 possibilities. One, it is concave left parabola, and one could be concave right parabola. So we will have 2 equations. Either it can be concave left or it can be concave right. That means here also you need to know that there will be 2 directrices. One directrix for this concave left and another directrix for this concave right. We don't know. So anyhow, you know, if I happen to have one directrix here, obviously this directrix is intersecting the x-axis, which means this directrix will intersect x-axis and it will be always parallel to y-axis. Now, I don't need this question here. Since the directrix is parallel to y-axis, it is parallel to y-axis and it is intersecting x-axis, because this is concave right, one is concave right and one is concave left. So since the directrix is parallel to y-axis, we can write let x is equivalent to k. I don't know this directrix. It might be intersecting anywhere. I don't know the point, but let me take this one as a k. But this directrix is intersecting the x-axis. So which implies we have x minus k is equivalent to 0. Here the k is completely an unknown value. I don't know where the directrix will intersect. It can intersect -5, -6, -1, -2, I don't know. So anyhow, I'm taking x minus x is equal to k. Now listen carefully. Now comes the real part. We know the definition of parabola is given by modulus of SP is equal to modulus of MP. Modulus of SP is equal to modulus of MP. And let me take this one as a L and say this is L dash. Is that okay? It's a lattice rectum. So modulus of SP is equal to modulus of NP. Now see this next step. Instead of modulus of SP, I am going to write modulus of SL. What's the meaning here? SP, suppose if you happen to take point P here, suppose a P of X comma Y. This SP, what I'm trying to say here it is, this line SP and SL is same. This is what I'm trying to say. S to this P, you take point P on the parabola. At certain point of time, this point P also will reach at L. So that means S to P is same as S to L. This is the important concept you need to understand here. If you happen to take point P on the parabola, S to P and S to L distance is equal. This is what I'm trying to say here. S to P and S to L is equal. I hope you can get it, this one, which is again equivalent to modulus of MP. Now what is this SL? SL is a length of semi-lattice rectum. Remember here, L to L dash is a length of lattice rectum, but S to L is a length of semi-lattice rectum. So L to L dash, how many units now? 1, 2, 3, 4. Oh, is this correct? Oh, okay. 1, 2, 3, 4, 5, 6 units. 6 is the length of a lattice rectum. So what will be semi-lattice rectum? SL will be nothing but is equivalent to 3 units. Semi-lattice rectum. Length of lattice rectum, you count it from here. You measure it. That means 1, 2, 3, 4, 5, 6. Then what will be semi-lattice rectum? Length of lattice rectum is 6 units, means semi-lattice rectum becomes 3 units, which is equal to MP is a perpendicular distance made by the directrix. So right now I took this as a directrix. So therefore modulus of X minus K divided by, you know the perpendicular distance formula. What's the coefficient X? 1 square. So now which implies we have modulus of X minus K is equivalent to 3. Square and root will get cancelled. Then this directrix, that means this directrix, or you like make, instead of directrix you can take this point now. This point, that means you can take this line. This line is passing through which point? It is passing through negative 2. This is the X value, this is a Y value. Taking directrix and taking this lattice rectum now, right now it is same. Because S to P and M to P is equal. So therefore you take S to L. So this line is passing through negative 2. So therefore substitute here, which implies X value is negative 2 minus K is equivalent to 3. Now this is a modulus. Modulus means either positive of negative 2 minus K is equal to 3, or either negative of negative 2 minus K is equal to 3. Modulus means you will have two values, either positive or negative. One is positive value, one it is negative value. Now open the bracket, we have now negative 2 minus K is equal to 3, which implies negative K is equivalent to 5, implies K is equal to negative 5. We have K value. Then another one, that implies we have, open the bracket, we have 2 plus K is equal to 3, implies what's the K value? K value is equal to 3 minus 2. Okay, negative, okay, 3 minus 2 we have is equivalent to 1. That means one directrix is passing through this point. Okay, let me draw, okay, let me redraw this, no problem here. One directrix, that means K is equal to 1. I took X is equal to K. One directrix passing through here, through this one point. This becomes one directrix D dash, say D1 dash, and another directrix passing through negative 5. Let me draw another directrix. Say this is D2 dash. I hope you got it now. We got two k values, means this k means x is equal to k, x is equal to 1 means this is the one, x is equal to 1, which implies x minus 1 is equal to 0. Another one is substitute here, x is equal to negative 5 implies x plus 5 is equal to 0. So this becomes the directrix for concave left parabola, and this becomes the directrix for concave right parabola. Now from here to calculate the equation of the parabola is much easier, because we have this focus point, we have the directrix. So now we can calculate the equation of the parabola. So let me first calculate which one. Okay, let me calculate the concave right parabola. Okay, let me take this point P here. Okay, let me take point P here, P of x comma y. From focus join this point, from point you join it here. Make sure this is 90 degree, this is M. Therefore, okay, modulus of, okay, equation of parabola, Now modulus of SP is equal to modulus of MP. Now from here the concept is same. That implies square root of SP, S to P, x minus of minus 2 becomes plus 2, x plus 2 whole square plus next one it is y minus of minus 1 becomes y plus 1 whole square is equal to, I am talking about concave right. So what's the directrix? This is the directrix. That means modulus of x minus 1 divided by root of 1 square. I will square on both sides. We have x square plus 4x plus 4 plus y square plus 2y plus 1 is equal to, here also you will square. So we have x square minus 2x plus 1. This x square will get cancel. Any cancellation? No. Therefore we have y square, bring here, plus 2y plus 6x, then 4 plus 1, 5, 5 minus 1. Here it is plus 4 is equal to 0. This is a required equation of the parabola. This is the equation for concave right. Let me go with another one. Equation of parabola. Equation of parabola for concave left. As usual, modulus of SP is equal to modulus of MP. So I have taken point P here. Join with this directrix. Say this is 90 degrees. Say this is point M. So what's the SP? As usual, it is same. SP is root of x plus 2 whole square plus y plus 1 whole square. But only the difference is the directrix. So what's the directrix? Modulus of x plus 5, which is root of 1 square is 1. Now shall I square on both sides? Expand it. X square plus 4x plus 4 plus y square plus 2y plus 1 is equal to, expand this, x square plus 10x plus 25. X square will get cancel. Final answer we have is y square plus 2y, 4x minus 10x is minus 6x, 4 plus 1, 5. Yes, correct, 4 plus 1 is 5. Bring here, it is negative 20 is equivalent to 0. Required equation of the parabola. So let me a little bit summarize. Let me summarize with this question. See, what we did was, we don't know the directrix. So therefore I took directrix x is equal to k. And when looking at this focus point and lattice rectum was joining 2 points, means you will get two parabola. It can be concave right or it can be concave left. So therefore what I did was, I calculated the k value by using the concept that S to P and S to L is same. I got two values of k, that means I got the two directrices. It should have two directrices because we are talking about two parabolas here. Then finally I calculated the two equations of the parabola. Thank you. If you have any doubt on this question, please ask or drop the message. You can personally message on me in Messenger, no problem. You can always ask the doubt. Thank you.